Thank you very much. There's not too many waterfalls in Ireland, but there's plenty of water coming from the sky, that's for sure. I'm actually really glad to be talking in the design track, because as a performance consultant, I tend to get bogged down in the nitty-gritty, the details of shaving off 100 milliseconds here, or helping analyze a load test there. Whereas actually, I realized that I spend more than half of my time not doing the detailed nitty-gritty, but working on selling a story. So selling the meaning and the value of web performance is probably right up there. Why should we buy your performance services? Well, performance is really important. Well, we don't see it. So half of my job at least has got to be convincing people of a story, of a point that I'm trying to sell. And I think that's pretty true of most people in this room. Whether you're trying to convince someone that containerization is a good idea, or that we should be using really advanced monitoring or load testing, you're trying to sell a story, to tell a point, and you're trying to use data to prove it, hopefully. So I've been reading a book called Talk Like TED lately. And if you haven't heard of TED Talks, I'd recommend looking up what they are. But this book is about analyzing the most popular, successful TED Talks. And right at the beginning, the author says, "A picture's worth 1,000 words." We've all heard that. And we're all storytellers. And I love that idea. We're trying to tell a story, whether it's that if we improve performance, we improve conversions, or if we change the design of the button, more people will click on it. It's a story we're trying to tell, backed up with data, hopefully. I think it's a little bit different than that because as a consultant, I do a little bit of selling. And we're all salespeople, whether we're telling a story to do it or not. We're trying to sell our points of view. I can tell that we're trying to sell our points of view if you just follow the hashtags or the conference Twitter handle. We're all trying to promote data and evidence and case studies, and there aren't enough of them to prove why we're all here, why performance is so important, whether it's within our business or to our clients, or even to each other and to ourselves. And we're not terribly good at selling it using visuals. So take a sales graph from an anonymous person or company here. It definitely needs a bit of work, because what it tells you is a great story. There is great data under here that faster, or users getting a faster user experience are more likely to convert, more likely to generate revenue for a business. But you can't tell that immediately from viewing the graph. It takes some interpretation. It takes some technical analysis to work out that actually the title's incorrect, it's missing an axis. And what's that orange bit at the bottom? Oh, it's the same as the blue line at the top. So we need to do a bit of work on how we present our data, because our data is really cool, but we're not very good at selling it. %3 of my presentation over? Yes. Really, as people who come to Velocity, whether you're a presenter or an exhibitor or someone coming to view the presentations, it's our job to use the best visualizations we can to tell our stories, whether it's repeating stories you've heard here or stories using your own experiences and data. This was kind of crystallized for me when my wife bought me a book for Christmas last year. And it's by a guy called David McCandless. And hands up if any of you have seen or read this book before. Ah, fantastic. That's why I know I'm in the design track. There's at least 10 people. And what David does is he takes data sets that he doesn't quite understand, maybe because they have too big a scale of magnitude, so it's hard to comprehend, or there's too many numbers. And he tries to visualize them in a way that makes more sense to him. And then he made a website, and then he made a book. Now he's made another book called Knowledge is Beautiful. And it kind of showed to me that even with the most mundane of data, like tax figures, if you get a good visualization, it can come to life. And now what I should do here is show you one of his visualizations. But I'm not going to. The reason that visualizations are so powerful is kind of exhibited when you look back in time. We've been doing it for a really long time. Before the spoken or written word, we were drawing pictures to represent stories, to warn people about things that can eat you or berries that can kill you, because we didn't have the way of putting our ideas on paper. Now we do. We don't even need the letters that we use. So the brain is really good at processing images, and it's really bad at processing characters, such as the letters in these words. Now, the reason we can read that sentence without looking at the characters that are in the words is because our brain is doing pattern matching. It's not actually reading. It's just saying, I've seen this word before, and it's the same as this one, so that's the meaning I should use. This is great for when you're speed reading, but it's less great when you're dyslexic and you have trouble distinguishing characters, or when people use weird fonts or all caps. So you can't actually pattern match, which means you have to slowly go through the characters. What we're really good at is processing patterns, outliers, shapes, size, scale, position, all these kind of things that are built into our brain. Using a process called pre-attentive processing, you can actually tell that the fifth cross is rotated slightly in under 200 milliseconds, before conscious thought kicks in to reason about why it's rotated. Now this gives us this amazing superpower as people presenting data. We can implant ideas into people's heads before they've even thought about it. Red is bad, green is good in Western culture. Big is big, large size, large bytes. Small is less important. We have this power which perhaps we're underutilizing. And we can do all this faster than conscious thought. How cool is that? And this is where infographics have come from. And this is an infographic from David McCandless's book. And if you can't see it, which you probably can't, it's called the billion eurogram. And it's taking numbers which, in context even, are really hard to comprehend. What's 500 billion euros to you or me? It's a huge amount of money, but how much different is that from 1 billion euros? Both of them are unattainable from a personal perspective. So having a list of numbers doesn't make much sense in that context. What this does is categorize the size of expenditure or cost using color. The scale is the number of billions of euros. And then it has titles such as income to France from wine, 16 billion euro. And the other one for France is, I'm going to get there. Foreign aid given. So France gives out in foreign aid as much as it gets in from wine. And that kind of relationship is really hard to tell from a list of numbers and tables. It also shows here in the right-hand side the lilac, the estimated cost of the war in Iraq in the small box versus the actual cost of the war on terror by 2010. So you can see the scale from the small one to the massive one quite instinctively. And these are powerful tools to use. Unfortunately, this takes a lot of time. These kind of graphs take David McCandless months to produce. So that got me thinking about what's the difference between an infographic, which we all know and love, and a visualization. Well, Noah Linsky defines an infographic as something that's handmade, something that tells a story in itself, whereas a visualization is something that can be computer generated. So where an infographic can be made up of multiple visualizations to tell a story, each visualization helps reinforce a story or present the data within a story. So we can't really make infographics for web performance stuff automatically, and being engineers or designers, you want to automate a lot of processes that don't need to be manual. But we can learn a lot from infographics. We can use size to represent scale. We can use position to represent inheritance or relationship, color and contrast to highlight things of interest or categorize, shape to categorize again or show importance, and then animation if you really want to stick animation in there to show movement perhaps or highlight an area of interest. So with all these tools, we should be able to produce really cool, engaging visualizations. And how does that relate to web performance? Well, pretty clearly now, over the last couple of years with RUM, we're getting a lot of data to deal with. And in terms of the realms of big data, we're not really to that scale as an industry, but we're going to be there soon. And it's happened very quickly. And as an industry, we need to keep up with that. So at the moment, we have kind of dashboarding tools by default, which show us, for example, 58.3 thousand page views. But from that screen, unless you've seen it before, you have no idea if that's per minute, per hour, per day, whether it's good or bad, or whether it's more or less than it was before. And for that, you say you look at the graph above it. But to me, that graph is pretty meaningless because it's just a wobbly line, and there's no real context as to what it's showing me. So as a visualization, it shows some data, but it's perhaps lacking in the ability to present a story to the consumer of that visualization. And unfortunately, our data can have a pretty high barrier of entry, in that you need technical insight to be able to analyze something like this. Everyone in this room can probably say that that's a pretty bad waterfall. But why do we say that? Probably because we've seen 100 before. 99.9% of the population of the world have not seen one of those before. And it's easy to forget that we're actually a really small community who can analyze this kind of data and tell stories around it. We shouldn't be relying on us to be able to tell web performance stories. We should be having pretty images to do it for us. I'll get into this in a bit more detail, but this heat map shows you how slow each part of the page is to load. Now compare that to a dashboard with lots of numbers. It's pretty easy to grasp if you assume red is bad and green is good, that there's a red thing around the edge which is pretty bad, there's some orange bits in the middle which are okay, and the bit around the edge is green, so that's good. And then the cookie banner at the bottom, well, that's always going to be bad because it comes in after load and it shifts the content, so that's yellow. So like I said, we are quite good at presenting our data in a technical context. 58.3 thousand page views. Cool. What we need to get better at is presenting our data in a business context in such a way that it doesn't need technical interpretation. So it's easily consumed by everyone in the business or everyone outside the business as well. So it makes sense out of context. And this is where I introduce Jane and have a glass of water. Talk amongst yourselves. So, Jane is a client of mine. She's the e-commerce director of a pretty large UK publishing firm. What I want to talk about is kind of the last year I've spent with Jane, going through her challenges, and then the way she's used visualizations to help her overcome those challenges. And it's a really nice crystallizing story because it uses multiple different types of visualizations to sell value into her business. Now, Jane has a challenge in that publishing is changing. Who here's bought a print magazine in the last month? Who here's downloaded some kind of online content from a web page or an online magazine in the past month? So that was about 20 people to 100 people. I'm quite impressed that 20 people still bought a magazine. What you'll probably find is a speciality magazine, something which you like to take on travels. So things like children's magazines and train spotting magazines are on the up, whereas your typical magazines such as men's and women's fashion are on the down. And in the UK year on year, we've just lost 8% of sales of print media. The reason for that is pretty obvious. The web gives us a much better channel to do it. We can publish quicker, we can syndicate content, we can access more consumers, and we can track it much better. So I don't know if you ever did a paper round when you were younger, but the number of people who take all the papers and just toss them over a bridge and then go around about their daily business. There was no way of tracking who received those papers. Of course, with an online magazine, you can see exactly who is visiting your site, what they're doing, and how long they're spending. So what we've done is take the print world of adverts and migrate it into the web world of adverts. And what it gives us is a website like OK Magazine, which is a big lifestyle magazine in Europe, where the content makes up 25% of the page. What we've got is a lot of advertising, which is really easy to manage, to monitor, to say, yes, this person saw this advert, here's 10p. And it's a great source of revenue for online media. Who here likes adverts on web pages? Two. Andy, I am not counting yours. One at the back, thank you very much. So this gave Jane a challenge. She knew that there were a lot of third parties on the site, but as a business, this UK publisher had no management strategy of all the third parties on the site, whether that's tracking or advertising or anything else. She said, I feel like all these adverts are having a bad effect on the user experience. Note the use of the word feel. She had no empirical data to back it up. So this is where I thought, aha, I've used web page test before. Let's do a pie chart of content breakdown by domains, which shows us the number of requests coming from each domain. And the one on the left is probably quite familiar to anyone who's looked at a bad website in web page test, where you've got hundreds of domains giving small amounts of content. Of course, you can block third parties on web page test, and you get the graph on the right, which shows you a pie with less slices in it, fewer slices, I should say. And in fact, this is technically incorrect because the total number of bytes has decreased. So if we then make it correct, these two charts are totally different from each other, make no sense out of context, and are pretty useless. So Jane said no. So I thought, aha, my trusty friend, the waterfall chart. I couldn't fit it on a slide, it was that bad, but that's third parties enabled and third parties disabled, and it's probably quite a familiar story. Of course, this takes technical understanding and doesn't tell a story. Also, who's to know what the future of these waterfall charts holds? With HTTP2 and new protocols, they're starting to become less relevant, and we need to look at different ways of visualizing our network traffic, our data, our render performance to our customers. So I thought, this is just a list of domains with a number of requests or number of bytes, which is words and weights. Lots of words, each one with a weighting. Who can tell me a good visualization for that? One word being 10, one word being 20. No one's used Wordle.net? You can make a word cloud, like a tag cloud, where that's a big domain, that's a small domain. But once again, this is losing a lot of the detail. You've got very small domains which are impossible to see. So I thought, what if we took the load time, the amount of network time, and then square root it to make it all fit on the screen, and we get a really pretty chart. The problem with this is it's almost totally irrelevant. Square root of load time means nothing, the colors mean nothing, and the direction of the domains means nothing. But it looks quite nice, and it proves a point. So at this point, I thought, it's time for the last resort. I'm trying to visualize what impact third parties have. Anyone give me an idea of the kind of visualization I may have used? A video, thank you. What we do is we take, with third parties and without third parties, we block one of the third parties, worst case scenario. And although I'd love to skip through another 1% of my presentation, we know that in Windows it'll take at least 20 seconds of a blank screen before the customer gets a website. On Mac OS, it's 150 seconds. Now this is kind of an unrealistic scenario. How often does a third-party domain go totally black hole? But what it did is prove the risk that third parties were having on the site. And this allowed Jane to get more time and money to investigate third parties properly. So, Jane's challenges, pretty obvious. And we've managed to prove a point using visualizations. Woo! And then the immediate response I got back was, well, it's OK, because we don't have that many third parties, which is a story as a business we hear all the time. And it gave me an idea. That's my favorite transition in the slide deck, by the way. That's me. It gave me an idea. What if we could plot the way that third parties interact with each other? What if we could show that Facebook was being called by Yahoo, which was being called by Google, which was being called by an advertising network, to prove how they all link together in this horrible piggybacking mess of advertising networks that we've all come to know and loathe? So I made RequestMap. And this is ebay.com through RequestMap. And what you can see is in the middle, there's a little blue blob, and that's all the content from ebay.com. On the left-hand side, you've got the green blob, and that's image CDN content from eBay. So this is your product images. You've got some yellow blobs, which are the JavaScript and CSS CDNs. And the size of those blobs shows you how much content is coming from each CDN. So immediately, you can see that they shard the images pretty evenly across those 4 domains. They don't have much from the .com. And then they've got lots of CSS and JavaScript stuff from the yellow ones. Now, the width of the line shows you how many requests there have been. And the length shows you how long those requests took on the network. So you can see there's this chain coming down the right-hand side, which is double-click calling other stuff. And that's their advertising network hopping customer data around. And what it gives you visually is an example of the use of size, of color, for categorization, of length, and of relationships, which is great when you're trying to just get an overview of what a web page looks like from a network perspective. So I did this on Jane's website. Shock and awe, gasps. So what this shows is that they've got 2 domains, a small blue one and a big blue one, which is their main domain and CDN. And then this horrible array of red stuff at the bottom, which is all their advertising networks talking to each other. And this was pretty revelatory for Jane. And this is what allowed us to continue working on third parties. But don't just take my word for it. Is Andy Nielsen in the room? Oh, I'm going to use your quotes, I'm afraid. Made them all up. But Andy's had a tough job working at M&S, driving a performance culture. And I like to think that RequestMap was quite important in that. Just shout a yes. Yes, thank you. So this helped Jane solve that challenge. Increase awareness of what's going on her sites that her customers are trying to interact with. Another one ticked off. So the first thing you think of is get rid of the third parties, which really doesn't work in online publishing, although I'd love it to happen. Those ads generate revenue, and in fact, they generate almost all the revenue apart from sponsored content. So you can't just rip them off the page. But Jane said to me, we have SLAs in place with our third parties, our advertising networks, about how quickly they should render their adverts to the screen. Some of them are enforced by us, because we want the adverts to render quickly. Some of them are enforced by our ad networks, because they want them to render quickly. Because the quicker they render, the more likely it is that a customer will click on it, generate revenue for Jane, and also generate revenue for the ad company. Can we show when the ads appear? Now, my first reaction to this is, of course we can. Film strips. But in true terms of visualizations, that's not a repeatable process. You can't say, for every web page test we're going to do, write down when the banner advert appears. So I looked at Mark Zeman's perf map which is a browser plugin which shows you how fast or slow images on the page render to the screen, which is fantastic, except it missed the advert because it does images and not third-party content. So then I thought, I'm a synthetic kind of guy. I use web page test a lot. I work for a synthetic monitoring company. Let's take a synthetic film strip and smush it together to produce a perf map, a heat map. Here we analyze every single pixel of every single frame and work out when it became visually complete, and then grade that against a budget. So say my budget here was, I think, 1 minute, using a testing speed of 2 meg, to say that, okay, the page rendered properly, the top banner rendered really quickly, the images in the middle rendered pretty slowly, they're about 20 seconds at 2 meg, but the real killer feature here is that the advertising network rendered in 52.2 seconds. That banner ad, which generates a lot of revenue for the business, is taking almost a minute to load under low bandwidth conditions. And you can imagine that this helped Jane go, we've got some success in analyzing this data and getting input from the business to say that we need to manage our third parties better. So we've created some value. And in fact, they started to make more money when they improved the performance of their ads. So if I were to plot all these visualizations on a chart, a meta chart, if you will, where the x-axis is the kind of scope of the test, the time of the test, whether we're looking at point in time or trends, and the y-axis is the scope of the test, whether you're analyzing a single page or the whole site. We've got a waterfall chart, which is point in time, 1 page, and hard to understand, so I've colored it red. We've got the film strip view, which is really obvious when you look at it. You could do multiple pages, but what it struggles in is trending over time. It's hard to view a film strip over time, although SpeedCurve have had a go at it. Then we've got the request map, which I've put kind of in yellow because it still needs some technical understanding. What are those CDN domains? What are those third parties? And are they important? Should they be 500 bytes or 2 kilobytes? And I've got heat map there, which I still think is quite green in terms of it's obvious what's going on. Green is good and red is bad. But it leaves us with quite a nice gap over here in the middle. So looking at important pages over time and trending that data. Now this is actually somewhere we're pretty comfortable with. If you look at free and open source solutions like Graphene and Graphite or any way of charting data over time, that's done. That's easy. We've got that day to day. You can enhance that by going to SpeedCurve, getting them to do it, and then showing film strip images and getting more rich data trending over time from a key number of pages. So yeah, we can track performance, but I don't think it's good enough. I think we're too focused. You pick your homepage, your competitor's homepage, a category page, a listing page, a product page. What if one of the other product pages has got bad? What if you've got a campaign page which marketing have just put up and not told you about, which you're not tracking? So we've got performance ops dashboards kind of in the middle there, but I still think there's a gap kind of further. We need to get more pages, more intelligence into our visualizations. Anyone agree with that? Do a bit of crowd participation? Yeah! Oh, yeah. Thank you. So that was 100% of people put their hand up. Well, 99%, you were the one who didn't. So I said to Jane, what can you give me in terms of data? She said, oh, we've got this thing called Google Analytics. Have you heard of it? Yeah. She said, there's a lot of data in that. I know I've got response times in it. Can we do something with this? And I thought about the different RUM solutions that are around. So we've got Google Analytics, which is a fantastic query explorer. I'll put these slides up on Twitter later. But you can go through and fiddle with any query in Google Analytics and get the data out raw as a TSV, which is really cool. New Relic has an API Explorer as well, so you can get your performance data right out of their RUM solution. Impulse has an API, but no Explorer, so it's quite difficult. And Pingdom doesn't yet have an API. But other RUM providers are available. So what if we were to use that data? We've got the most popular pages, exit rates, bounce rates, performance, to present a more cohesive visualization which tells the story in itself, that doesn't need technical interpretation. Now, I'm selling myself high here. What if we could get this Mondrian piece of art to represent real data about our website, to update live, where the height of a block, where each block is a page on your site, is the number of page views. So the taller it is, the more popular it is, the more customers are going to it. Where the width is the exit rate, so the rate at which people leave their web journey on that page. And then use the color to represent this key feature, performance. That gives us a three-dimensional space to work with where we can say a big red blob is somewhere we need to investigate. It's popular, lots of people are leaving the site there, and it's poor performance. So is it performance that's driving people away? So using Google's API Explorer, I built it with horrible neon colors. I'm sorry for that. It is at runwall.webperf.tools to have a play with. You can use your real Google Analytics account, and it's one HTML file, so all the sources in the client. So feel free to copy it. But what we've got here is a real client's Google Analytics data, anonymized of course, where the home page has the highest number of page views, which is what you'd expect. And it has a reasonable exit rate, which is what you'd expect. And a reasonable performance, which is kind of what you expect. So this is all reassuring. It's green and tall and squidge. This was a blog post that had gone live recently, selling or advertising a new product, which doesn't have a huge amount of page views because it's a blog post on a commercial website. What it does have is a high exit rate and a low performance, potentially. So are they linked, and should they be investigated? Probably. Then we've got a category listing page, which is the main category of the site, which has lots of people viewing it, a reasonable exit rate, but you think people going to a category page are probably going to go to a product. But it still needs some investigation because the performance isn't great because it's orange. Now the big glaring obvious one here, hopefully, if everyone spotted it, is the big red one. So this was a campaign landing page. So this is something that marketing had put live, which wasn't being monitored or tracked by any other tool in their performance repertoire, which was not having great results. E-commerce weren't happy because there wasn't a great conversion rate coming off it, but no one knew why, and WebOps hadn't been told about it. It'd just been pushed through the CMS. So this is a great cause for concern because it's big and red. So lots of people are hitting it, lots of people are going away unsatisfied, potentially, and it's got a poor performance. So that shows the power of visualizations when you're talking about web performance data. Hopefully, not if you agree. Yeah. 5 nods, yes. The key of this isn't that I built some pretty thing. It's more about you've got a lot of data, probably within your business, or that you have access to from your clients. And we shouldn't restrict ourselves to the tools that we know and love, the open source dashboarding tools, the commercial performance monitoring tools. We should think about how we can use that data better to serve our needs, which is selling our story of web performance. I'm not done yet, though. So we've got this kind of higher and top right. I've put it green again. Notice I've made most of mine green. So what this has done is helped Jane track performance over time. So this is a dashboard that runs and updates every 10 minutes. Google Analytics data updates about every 10 minutes, so it works out pretty well. So I'm going to tick that off the list. But analysis is only the beginning. What we also do in web performance is check performance on build. Anyone do that? Is that 4 hands? 5 hands? No one else does performance analysis at build time. Wow. Okay, so we should be doing performance analysis at build time to make sure we're not introducing regressions of 20% or otherwise. But what we should also be doing is visualizing those changes. So Brett Slatkin at Google, anyone seen his velocity or his presentation on perceptual difference? Oh, it's all brand new to you. So he's introduced a tool into the Google feedback tool. I can't remember what it's called. Where every time they run a build, a perceptual difference tool is run. So it uses Phantom.js to load the web page before and after build and does a quick diff on the pixels. And anything that's changed comes out red on the left-hand side. Now, from a human perspective, looking at the 2 images on the right-hand side, it's really hard to see any difference whatsoever, not just because of the dodgy projector. What the visualization does is draw your attention to things that have changed, which may be regressions which are creeping in over time. It may be someone changing the font resource accidentally, so the text is slightly red, or it may be a more fundamental change. But without the visualization, you may not know it's there. So the reference to his talk is there, and it's very good. Something that we do a lot in web performance is alert. This has got slow. This has got X% slow, and it's now at this many milliseconds, and it's been like this for 40 minutes. We should do something about it. Now, in terms of the context of that alert, it means pretty much nothing. It means you'll log into whatever tool generated the alert, you'll look at the data, you'll do your own rules of thumb, and you'll say, is this a good alert or is it a bad alert? Should we focus more on it? Now, what Alison McKnight at Etsy has done is developed alerts with context. So sticking some visualizations into this email shows immediately to a human that there has been a significant difference, that it's been happening for a reasonable amount of time. This doesn't happen all the time, And here's a link to go directly to the dashboard, which shows these graphs and others, including context of other processes which rely on the same architecture and infrastructure. So you can see if it's an infrastructure issue or if it's an application issue with one view of a screen. Now, I think that's really cool and something we should all be thinking about. So that's building visualizations into business processes. And I'm not going to say that's an exhaustive list, but it should give you an idea of the kind of things you can look into to make it easier to consume the data that you've got or that you're creating. And don't fear failure. There's no coincidence that both of these visualizations are round, but both of these are visualizations that don't give any data away. But there's no harm in creating them. Play with D3.js, play with Excel, or don't. But try to get your data in a way that makes sense to you. And if you can't get it to work, there's places to get help. A relatively new site called helpmeviz.com. You can throw in data and your attempted visualizations, and HelpMeViz will tweet it out and get constructive feedback on how better to visualize that data. So I'd highly recommend going there. If nothing else, just to get an idea of the kind of visualizations that people are using. And use the right tools for the job. You don't have to remember all this. If you go to webperf.tools, it'll take you to a post on my blog, which just has a list of the tools that I've referenced in here, including SpeedCurve and Yellow Lab and the ones that I've created. Now, if you want some homework, I know everyone loves homework, I'd recommend getting a book out of your library. So Information is Beautiful is a great introduction to different types of visualizations. Data Visualizations by Noah Linsky is quite technical and takes a lot of reading, but it is very good for that base technical understanding of why visualizations are hard to make, but why they're good to consume. And Storytelling with Data will be coming out in about a month, and I'm pretty sure this is going to be a fantastic book, which will far exceed your expectations that I've set in my presentation. So that's been me. Thank you very much. Now, I'm not going to ask if anyone's got questions because everyone says no, but if anyone really does have a question, shout. See, I knew you wouldn't. Oh, go on then.
So, in your presentation, you mentioned that with gathering all the stuff about ROM, there's a lot of data around. So, one problem we have right now is getting a lot of performance data on various different channels, web, mobile, across the globe.
Yeah.
It's very difficult to visualize that in a way that makes sense to execs, and then they can follow if you're getting slower in China or getting better in Japan. Do you have any visualization
View. So the question was, with RUM, we're collecting lots of data from different device types, from different countries, on the different connections, and you can't visualize all that in one go. So how can we, or yet?
You can visualize the trend.
A trend over time.
You can do it. You can have it on geo.
Yep. So the map was the one good visualization, I think, from the screen I showed you before, which shows you things are slow and things are good. But that was for all traffic, not categorized by mobile or tablet. I think there's a few things we can do, such as the speed curve visualization that shows you different viewports and how things are rendering. But in terms of trending over time, spark lines. Put a lot of different charts in one place, but make them obvious. So if you see lots of things trending up, you know it's a trend that's across all devices, across all countries. Prioritize by your top 80% of devices in your top 80% of countries, and plot the spark lines on one screen. So you can see if one line goes down, you need to focus there. And that's maybe because iOS in China has started to have an issue. That's a good way to present a lot of data in one view, but it still requires technical understanding. Then you can take your spark line a little bit further by thresholding it and showing it red or green based on which way it's going. So it draws your eye to it. But that's a really good question, and one that's the best answer I got, I think, right now. Any more questions? Well, as the slide says, it's now break, so go enjoy some coffee. I will be. Thank you.